Let's now get some practice in creating Boolean expressions. So we've done some practice where somebody else wrote some Boolean expressions and we're evaluating them. Now let's get some practice writing the Boolean expressions ourselves. When you're writing Boolean expressions to represent something in a computer program, you'll always have a word problem description of what you're trying to create. So in here it says a person should get a COVID test if they have a temperature of 100 or more and they have a cough. Our first step is identifying and declaring some appropriate variables that we could use in the expression. And then we're going to write the Boolean expression so that it's true if the person should get tested. Take a minute and think about what variables would make sense for this particular word problem. You can think about what would be a good identifier for those values and also what data type would be appropriate. Our decision here about whether somebody should get a COVID test is based on their temperature. So we would need to store a temperature value within our program. And I would make that a double because temperatures can be things like 98.6. And so it's very possible that their temperature has a decimal component. The other factor for deciding whether someone should get a COVID test is whether or not they have a cough. And that would be a true false value. Either they do have a cough or they don't have a cough. So that would be a Boolean value, and I'm going to call it has cough. Now, if we were doing this in a computer program to make a decision about whether somebody should get tested, we would likely spend some time allowing the user to enter the data using standard input. So we could write a prompt that asks them to enter their temperature and then write a input statement to read from the scanner that temperature value. And then we would likely prompt to say, do you have a cough? And then we could read in that value into our program. For the purpose of this example, I'm just going to put a dot, dot, dot here. That means that's where we would do the actual input and output so that these variables have values. But we're focused primarily on writing this Boolean expression. That's our goal in this practice. So I'm going to declare a Boolean value, and I'm going to call it get tested. And I'm going to use that to store the result of my thought experiment. Should somebody get tested? How would I capture that in a Boolean expression? My expression needs to compare the person's temperature to a value of 100. And I want to know, is their temperature greater than or equal to 100? And then we also want to recommend that they get tested if they have a cough. So I'm going to write has cough is true. And together, those two factors decide whether somebody should get tested. If they have a high temperature and a cough, we want them to get tested. If they just have a high temperature, we're not recommending to test for COVID. Similarly, if they just have a cough, maybe they just need to clear their throat or something and they're not even sick. So we're not going to recommend that they get tested. And certainly, if they don't have a high temperature and also don't have a cough, then we wouldn't recommend that they get tested. If you're working on something like this on your own, you could always type this into IntelliJ to test it out. Let me pull up an IntelliJ window so that we can do that. So I'm adding in my variables. And since I'm testing this out, I should go ahead and add the actual input and output. I'm going to add in a scanner declaration. And it's totally fine if at this stage you're still looking up that exact syntax for the scanner statement. We're going to use it over and over again. In another week or so, that should just be second nature, where you, at the beginning of every program, think, oh, I should add in the utility library and I should declare a scanner because I'm probably going to need some input and output. So I'm adding in a prompt for the temperature, and then I'm going to read that in from user input using a scanner method. And then I'm going to do the same for the has cough. And so I'm going to use the scanner method next Boolean for that. And then finally, just so we know what the answer is, I'm going to print out the value of get tested. just so we can see the results. So now we're running the program. Oop, I forgot the semicolon at the end of my Boolean expression. But isn't it nice that Java comes up and the compiler will tell you that you're missing the semicolon, then you know to go look at it at the end of the indicated line. So it told me line 13 and it also highlighted it for me. All right, so if I have a temperature of 104 and I have a cough, then I should get tested because I have the high temperature and a cough. If I have a high temperature and I do not have a cough, it's going to tell me don't bother get tested. In that situation, maybe I just have a virus or something, a different kind of virus. Similarly, if I have a normal temperature and I have a cough, it's not going to recommend that I get tested. And if I have a normal temperature and don't have a cough, I definitely don't need to get tested. Super. So we tested out that program in IntelliJ in addition to writing it in our class notes. You can always do that with examples that you're working on for any kind of lab assignment, or if you're reviewing your notes, or if you are working on a project. Let's look at this next example. It tells us that a store gives a discount to a customer that is shopping for the first time or any customer that spends $50 or more. Identify appropriate variables for the expression, then write an expression that's true if the store should give a discount to the customer. So again, pause the video for a few minutes and think about what variables would be appropriate for your program. What kind of data type and what identifier would you use for those to be descriptive? And you can also brainstorm how you would build that expression. So in this program, we want to capture logic for whether or not the customer is shopping for the first time. So that's going to be a true false answer. So I'm going to make a Boolean variable. First time shopper. And then it's also based on how much money the customer spends. So we want to know their total expenditure, and that's going to be a dollar amount. So that could be a double. I called mine first time shopper and amount spent, but certainly you could have different identifiers there as long as they were descriptive. And then I also want to keep track of the decision that I make, whether it's true or false. We want to make an expression that represents whether someone should get the discount or not. So I'm going to call it gets discount. And that's going to store the result of my full decision-making process where I want the result to be true if the person is a first-time shopper. And I also want to consider whether they spent more than $50. And then what operator do I want to use to join these two expressions together? Should it be and or should it be or? In this example, it should be an or because it tells us that we want to extend the discount for either of these situations. So if someone's a first-time shopper, they get the discount. If they spend more than $50, they get the discount. And certainly if both are true, if they're a first-time shopper and they spend more than $50, they certainly qualified for the discount. This time I'm going to remember to put the semicolon in there. I'm going to go ahead and add it for the example above as well. At this stage, you could stop and test out your expression using IntelliJ to ensure that you have the correct solution. Let's look at a few examples of common errors that students make when they're writing Boolean expressions. One type of logic that students often want to capture in a program is whether a variable is between two threshold values. So they want to capture something like, is X between the values of 50 and 100? Unfortunately, if you write the expression like that in Java, it can't evaluate it. Instead, you have to write it as two separate comparisons. So first comparing X to see if it's bigger than 50, and then saying, I also want to make sure that X is less than 100. That means you join those two expressions together using the and operator. Let's test that out in IntelliJ. I'm just going to add it to my temperature example that I already had. Suppose that I had my variable temperature that I read in, and then I want to test to see is the temperature between 90 and 110, because maybe if it's not in that range, it means they've made some sort of typo in the input. So I want to check to see is the temperature value between 90 and 110. You can see when you type that in Java, it's red and underlined. If we try to compile it, it's going to give us an error message where it says bad operator type for a binary operator less than. In other words, it doesn't know how to join all of these ideas together in this format. Instead, to capture this same idea, we have to say if the temperature is bigger than 90 and the temperature is less than 110, that's going to accurately capture that same idea, but now it's in a way that Java understands. So everything's compiling and would work well. Let's look at another common error. A lot of times students want to know whether a variable has one of several values. So in other words, you want to know is the value of the variable x a 5 or a 6 or a 7? Again, Java can't compile it if you stack all of those comparisons together. Instead, you have to check to see is x equal to 5 or is x equal to 6 or is x equal to 7. So you're just repeating the equality check. It doesn't know how to evaluate this expression, 5 or 6 or 7. It only knows how to compare a variable to one of these values. And again, if you type it into IntelliJ, you'll see that doesn't like the expression, say we were checking to see is the temperature equal to 98 or 99 or 100. It's red and underlined because it doesn't know how to evaluate that. Your program won't compile if you write it in that format. What you can write is the temperature equal to 98 or is the temperature equal to 99 or is the temperature equal to 100. That's going to work just fine. Another thing I didn't mention earlier is that Java doesn't care about the spacing around these operators. I usually put a space before the operator and after the operator just to make it easier to read, but Java's perfectly happy to compile it if you don't include the spaces in there. It always just ignores the spaces. So you can use either format, whatever feels right to you. So I've been doing lots of examples of how Java evaluates Boolean expressions. There's an additional idea that's used in computer programs to save time, and that's the idea of short circuit evaluation. This allows the computer to skip over a part of a Boolean expression if it can already figure out what the result is from the beginning part of the expression. It always evaluates the logical expression from left to right, and it stops as soon as it knows the final truth value. Let's look at an example. So we're assuming that we have three variables declared in our program, an age, which is storing the value 25, a height, which is storing the value 70, and a weight that's storing the value 150. Suppose we were evaluating this expression. Is age bigger than 50 and is the height bigger than 60? Let's think how the expression would be evaluated. So first step, I'm going to go through and fill in my data values. So the age is 25 and the height is 70. Now I'm going to evaluate the expression on the left. Is 25 bigger than 50? That is false. 25 is not bigger than 50. And then we have the second part of the expression here. And the question we want to ask ourselves is, would the value of this second expression impact the final result of the overall expression? So if I have false and something, does it matter what this something is? No, it doesn't, because if this second expression is false, false and false is false. On the other hand, if this second expression is true, it doesn't change the outcome of the final expression because the expression false and true is still false. So the evaluation can stop after just evaluating this first part of the expression. And that's because it knows the final answer for the full expression is false. So in this case, yes, the evaluation stops after that first clause because the final result of the full expression is known without evaluating the second half of the expression. Let's do another example. Suppose we are comparing the height to 60 and the age to 40. So again, I'm going to fill in my values. Is 70 bigger than 60 or is 25 bigger than 40? So I'm going to evaluate the expression on the left first. Is 70 bigger than 60? That's true. And then I need to ask myself, does it matter what happens in the second expression? Would that influence the final answer? The second expression wouldn't influence the final answer. That's because the result of an or operator is true if either or both operands is true. So if this second expression is true, my final answer is true. If this second expression is false, the whole final answer is still true because of the first part. So my final answer is true regardless of what that second expression is. The computer wouldn't even bother to look at whether 25 was bigger than 40. It just allows it to save some time. So again, this one is yes, it's going to stop after the first clause because the final result of true is based on just the first expression. Let's look at one more example and figure out whether the expression would engage short circuit evaluation or whether it has to look at the entire expression. So for this one, we're comparing the height. Height is 70 and the age is 25. So evaluate the first expression and then ask yourself, would I also need to evaluate the second part of the expression? This first expression is going to evaluate to be true. 70 is less than 80. And then I need to ask myself, would I need to evaluate the second part of the expression? Does it influence the final answer? In this case, it does, because the result of the AND operation is true only if both operands are true. So if the second operand is true, the full expression will be true. If the second expression is false, the full expression will be false. So I do have to evaluate the second expression in this case. So I need to ask myself, is 25 greater than or equal to 20? That turns out to be true, and then true and true, the final answer will be true. So this time we couldn't stop after evaluating the first clause because both of the expressions were needed to determine the final answer. Super. At this point, we've talked about Boolean expressions, the various components that can make up a Boolean expression, including variables, literals, arithmetic operators, relational operators, and Boolean operators. We also did some examples where we evaluated Boolean expressions to determine whether they had a true or false result. And we did some practice writing Boolean expressions to capture the logic of different decisions that we might need to make. And finally, we learned about short circuit evaluation, which allows the computer to save time by not fully evaluating an expression when it can determine the final answer without looking at all components of the Boolean expression. If you have any questions about the Boolean expression topic, please don't hesitate to post on the discussion board in our Canvas page, and I'd be happy to respond to any questions that are posted there.